Hi everyone. In this video, we're going to focus on comparing fractions and a few strategies for doing so. Before we talk about comparing fractions, however, I'd like to review the density property and what we did when we tried to compare the fraction 10/21 and 5/11. So what we did, we said, well, okay, how do you compare those 21st and 11ths? We have to make them comparable. That makes sense. If you want to compare something, you make them comparable. So what we did was we found the least common multiple and created equivalent fractions. So the least common multiple of 21 and 11 was 231. And we said, okay, to create a fraction with 231, we multiplied the top and the bottom by 11. That's how you create equivalent fractions. So 10/21 is the same as, it's equivalent to 110 over 231. 5/11ths with the LCM, the least common multiple, which is the least common divisor, the LCD, is 105 out of 231. We multiply the top and the bottom by 21. Those are equivalent. We said, okay, well, what falls between 105 231st and 110 231st? That's 107 or 108 or 109 or 106. So there's lots of them. Actually, there's an infinite number between those two, but here's one of them. The density property says you can find at least one. So what we said is that 107 is between 107 231st is between 10/21 and 5/11. But for this video, what I want to focus on is that 5/11 is 105 231. 10/21 is 110 231. So what we can say is that 10 out of 21, or 10/21, is actually greater than 5/11. All right, so by comparisons, we're saying with a fraction like 10/21 and 5/11, there are three choices. Either they could be equal, 10/21 could be greater than, so they could be equal, they could be greater than, or, and that should be a less than, excuse me. So 10/21 could be less than 5/11, greater than, equal to, or less than. Those are the only options. And just so you know that this is something that you will be doing as elementary teachers, here is a activity off of a teacher's worksheet. Compare these fractions, doing it visually with pieces of the pie. So I advertised we're going to look at a few strategies. The first strategy is simply using your calculator and knowing that a fraction, a over b, remember that one of the concepts of the fraction is the fraction is a number. And what is that number equivalent to? A over b can be thought of as a divided by b. So 5/11 is 5 divided by 11th. 10/21 is 10 divided by 21. So let's go ahead and do that. Let me bring up my calculator. And let's move it down here. We've got 5/11, so 5 divided by 11. Oh, let me go back up. Equals 0.45, repeating, 4545. Okay, so let me go get my pen. And 0.45 repeating here, 0.4545, and on. So 0.45 repeating. Okay, so how about 10/21? So I've got 10 divided by 21, and that equals 0.47619 and lots of other digits. So 0.47619. We'll go with that for now, plus a little bit more. Okay, so 10/21 equals 0.47619, and it keeps going. And you can see that 10/21 is greater than 5/11. So strategy number one, just use your calculator, convert the decimals to numbers and compare the numbers. Strategy number two is doing more or less what we did when we examined the density property. It's called the common denominator strategy. Let's write these two fractions, 10/21 and 5/11, over common denominators. It doesn't need to be the least common denominator, although that's nice if you do that, but just a common denominator. Now, the least common denominator is the least common multiple of the denominators, 2/31. We've already done that, actually reviewed it in the density property, the very first slide we talked about on this lesson. And so 10/21 is 110, 2/31. 5/11 is 105 2/31. Well, this is where you think of fractions as parts and wholes. 110 out of 231 equal parts is more than 105 out of 231 equal parts. So that number is greater than that number. But the number on the left is 10/21. That's equivalent. The number on the right is equivalent to 5/11. So what that says is that 10/21 is greater than 5/11. Fortunately, that confirms what we did earlier. It better be greater. We got it greater once. We have it greater twice now. Let's go for the trifecta. And this is the last property, last strategy. And it's not complicated, but it uses a little more advanced mathematics. This is one that I would not start with children, but it's one that you eventually will get to. And it uses what are called the multiplicative properties of equality and inequality. So what these properties say, and these are things that are often used in algebras, is that if A is equal to B, if two numbers are equal, well, you can multiply each number by the same number, and we'll talk about x's as natural numbers. So if a equals b, then a times x equals b times x. Now, a natural number is a counting number. It's positive. So if a is greater than b, which is the multiplicative property of equality, then a times x is greater than bx. So how does that get used to compare fractions? Well, what we're going to do is we're going to look at these two fractions, a over b and c over d, and say, well, what if they were equal? What do we know? Well, if they're equal, what I can do by the multiplicative property of equality is multiply each by the same thing, and I'm going to multiply it by b times d. So I'll multiply each side by b times d. But notice something nice that happens here. When you multiply them by b times d, you get this b cancels with that b, so you're left with a times d on the right, on the left, excuse me. This d on the bottom cancels with this d, so you're left with c times b. So if a over b equals c over d, then AD equals CB, and it actually is a two-way relationship, meaning that the reverse is true as well. If AD equals CB, that says that A over B equals C over D. Okay, well that leads to three cross-product strategies. Why is this called the cross product? Because essentially all that you did was you cross-multiplied. All right, so if you have two fractions, A over B, C over D, if AD equals CB, then the fractions are equal. If AD is greater than CB, then A over B is greater than C over D. And if AD is less than CB, then A over B is less than C over D. All right, lots of A's, B's, C's, and D's. Let's do this with an example. Okay, so, oh my gosh, 10 over 21 and 5 over 11. Where have we seen those before? Well, you got to keep track of what number is what. That's what's For the cross product strategy, here's my A over B, my C over D. We said that A times D, that would be 10 times 11. You got to keep that number on the, essentially on the same side, so A on the left. AD is 10 over 10 times 11, which is 110. C times B, 5 times 21 is 105. So what does that say? That says that AD, 110, is greater than CB, which is the 105. Again, so you see you've got to keep track of what side these are on. So if AD is greater than CB, that says that these fractions, A over B, 10 over 21, is greater than C over D, 5 over 11.